Hello and welcome to the second marathon on differentiation for P3. I will be solving another 10 questions for you today, and I hope this is productive. Please make sure to like, subscribe, and comment if you have any questions. Okay, beginning with November 12, variant 3-1, question number 8. It says the diagram shows the curve this and its maximum point M. Find the exact value of the x coordinate of M. So I need to calculate dy by dx. I'm going to say that u is equals to e power minus half x square and v equals to root of 1 plus 2x square. U dash becomes e power minus half x square into differentiating with this would give you minus 2 over 2 x power 1. Okay, and v dash would be, so this is 1 plus 2x square power half. I will get half 1 plus 2x square half minus 1 into 4x. So dy by dx is then u dash v plus v dash u. Okay. So u dash is minus x e power minus half x square u dash v plus v dash u. Okay. From this, then I can see that there is something common, which is e power minus half x square. So that leaves me with this in the bracket, and I'm going to take this into the denominator and say that this is 1 plus 2x squared. So either this equals to 0 or that equals to 0. This obviously can't be 0, but because exponentials are not never 0, so not possible. Let's try to solve this one and see what we get. This is a more complicated expression than I thought it would be, but let's try to simplify this as much as we can. And I get this. I moved it to the other side and I've gotten this to be positive. Then I cross multiply. So I get 2x equals to x into 1 plus 2x square. The the root gets multiplied with the root and gives you the expression only. Then the best way to solve this would be to say that I can bring it to this side and I can again pull out x as a common, so I get 2 minus 1 minus 2x squared equals to 0. So either this equals to 0 or 1 minus 2x squared equals to 0. 1 equals to 2x squared, x squared equals to half, and x is therefore root of half. I think that looks like the final answer. Exact value of the x coordinate of M. Yes, it should be both positive and negative, but it's obvious that I'm going to only take the positive because it's bearing on the positive side of the equation. Okay, so that's the entire solution for you to view if you want to note it down. Okay, going back, doing question number 2 now. It says the equation of a curve is y equals to x plus cos 2x, and find the coordinates of the stationary points of the curve and determine the nature of each of these stationary points. I think that sounds simple. So 1 plus minus sine 2x into 2, 0 equals to 1 minus 2 sine 2x. So 2 sine 2x should equal 1. Sine 2x should equal half. Putting it out in quadrants, quadrant 1 and quadrant 2, alpha should be sine inverse of half. which is pi over 6. So quadrant 1 is 2x equals to pi over 6, and quadrant 3 is 2x equals to pi minus pi over 6. So I get 5 pi over 12, and I get pi over 12 from here. Now, in order to determine the nature of these stationary points, what I'm going to do is I'm going to write dy by dx equals to 1 minus 2 sine 2x, and I'm going to double differentiate this into 2. So I get minus 4 cos 2x. So using these in the double differential will tell me whether they are maximum points or minimum points. So minus 4 cos 2 into pi over 12. Okay, that gives me possibly a negative answer. I have my calculator in front of me. Okay, and pi over 6. I get minus 2 root 3. So x equals to pi over 12 is a max. Let's check the other one. Cos 5 pi over 12. So minus 4 cos 5 pi divided by 12. 5 pi over 12 was multiplied by 2, 2 into 5 pi over 7. So that's 5 pi over 6. That's 2 root 3. That's positive, therefore minimum. Okay, a reasonably simple question for 7 marks. I can zoom out and you can see the entire thing in one go. Then the next question says the equation of a curve is this. I see a quotient, so show that the gradient of the curve at the point for which x equals to ln 3 is 9 over 50. So this is a question where I need to show that something. So I'm going to go with dy by dx is u and v. So u is equals to e power 2x, v equals to 1 plus e power 2x. This is the quotient rule that I'm trying to do. V dash is 2e2x again. So dy by dx is u dash v plus v, sorry, minus v dash u over v squared. So dy by dx is then 2e2x into 1 plus e2x minus 2e2x into e2x over v squared. Now it says show that the gradient of the curve at the point for which x equals to ln 3 is 9 over 50. So I have to use x as ln 3. ln 3 1 plus e power 2 ln 3 minus 2 e power 2 ln 3. It would have been easier had I just sort of factorized this first and then plugged in ln 3 instead of x, but this is fine too. So I get 2, and honestly I could do this on a calculator and sort of I could get your final answer and that should match hopefully. But just as something on the sides, ln 2 ln 3 is basically ln 9, and when e and ln cancel each other, the number gets multiplied as a coefficient, so I get 18 out of this. So that was basically 2 into 9. I could say then this is 1 plus 9 minus 2 into 9 and into another 9 divided by 1 plus 9, and that's the full square. Okay, so that's 18 into 10 minus 2 into 9 into 9. That gives me another 18, and the denominator is 100, so that gives me 9 over 50. Okay, so that's dy by dx at x equals to ln 3. Moving on to question number 4. It says the curve with equation e power this has one stationary point. Find the exact values of the x coordinates. So again, dy by dx is the quotient rule. So u equals to e power 2x and v equals to 4 plus e power 3x. V dash is 3e3x and u dash is 2e2x. So dy by dx, again the quotient rule, I'm not writing the quotient rule again. If you still don't remember it, please scroll back to the video and you should be able to see it. U dash v minus v dash u over v squared. This time I want to find the stationary point, find the exact values. So stationary point means that I have to equate this to 0. Let's figure out what is common. I see e power 2x is common. So I'm going to say that this is 2 into 4 plus e power 3x minus 3 e power 3x. And the denominator actually gets cross multiplied. I'm going to do that in the next step. And that gets equated to 0. Okay. So 0 is e power 2x. 8 plus 2e3x minus 3e3x. So either that equals to 0 or this equals to 0, which is 8 minus e power 3x. 2 minus 3 gives me minus 1 equals to 0. 8 equals to e power 3x. Taking an ln on both sides gives me 3x equals to ln 8 and x equals to ln 8 divided by 3. That's the exact value of the x coordinate. Although it says ln2 here, that is basically the same as ln8 divided by 3, and I can prove that to you. This is not possible. I hope that you already understood that. And x equals to ln8 divided by 3 is basically ln2 cube over 3, so x equals to 3 ln2 over 3. So x equals to ln2. That's x. Can I quickly calculate y for myself? Y equals to e 2 ln2 over 4 plus e 3 ln2. So 2 ln2 gives me 4, e power ln4 gives me 4, and 4 plus 9. So I get no, that's not 9, that's 8. It's 2 cubed. So 4 over 12 gives me 1/3. So ln2 comma 1/3. Okay, if you don't understand the calculations, you can ideally put each of these individual terms on your calculator and you can find out the final answer. Okay, then I have this next question which says a curve has a stationary point as equation this. For this, express dy by dx in terms of this. Now this question is going to bother a lot of people and you should look at this carefully. Y equals to 2/3 ln 1 plus 3 cos square x. So dy by dx gives me, if I keep 2/3 outside, that makes it easier for me, 1 over 1 plus 3 cos square x into 0 plus, now in order to differentiate cos square x, you write it like that, and you differentiate the power first, you get power 1, and then you differentiate what's inside the bracket. So you get 2/3 minus 6 sin x cos x to 1 plus 3 cos square x. I know that this cancels out, and I know that this gut feeling that this changes to sine 2x, but it's unnecessary because the question is not asking you to calculate something in terms of sine 2x. It's actually asking you to calculate for tan x, which is awkward, right? Because I don't have anything in tan x, but I know that tan x comes up when I have sine x divided by cos x. Okay, okay, so I know that this sin x that I have in the numerator can be converted to cos x, but what about the cos x? So whenever you have to convert something into sine into tan, then remember that you have to divide everything by cos x or cos square x or cos 2x depending on what situation you are in. Okay, so here what strikes me is that I could divide this entire numerator by cos square x. And I could also divide this entire numerator denominator by cos square x. So that keeps the balance in the expression. I've not distorted the balance. I've done the same thing in the numerator and in the denominator. And now what I'm saying is that this basically cos x cancels out with cos x, and I get 2 tan x in the numerator, and then I have sec square x plus 3. What that gives me is that identity. I know that sec square x is an identity which is equals to 1 plus tan square x. So I get 1 plus tan square x plus 3. So it ultimately becomes what? It ultimately becomes 2 times, so it becomes minus 4 times tan x over 4 plus tan square x. Is that the answer? Yes. Okay. Then in the second part it says find the x coordinates of the point on the curve where the gradient is minus 1. So I know that I just need to equate this to minus 1. Now if you haven't done the part in part 1 correctly, then it's most likely that you won't be able to do part 2 correctly either. Okay, and since this is just a 2-mark question, I am assuming it's not that difficult. This is part 2. So minus 1 equals to minus 4 tan x or 4 plus tan square x. Cross multiplying. So tan square x minus 4 tan x plus 4. Okay, solving this quadratic on my calculator, although I pretty much see the answer. I'm just doing it as a formality. So I get tan x equals to 2. I just get one answer. I know that my x coordinate has to be in the first quadrant, so I don't really need to bother with a lot of things. I can just say that tan inverse of 2 and x quadrant 1 x equals to whatever tan inverse of 2 is. So tan inverse of 2 is 1.11. Is that the correct answer? Yes, that is the correct answer. Okay, so 5 questions down. Let's look at the sixth one. It says a curve has equation y equals to cos x cos 2x. Find the x coordinate of the stationary point on the curve in the interval, giving your answer correct to 3 significant figures. So u equals to cos x, v equals to cos 2x, u dash is minus sin x, and v dash is minus sine 2x into 2. So I get dy by dx as okay, dy by dx as u dash v plus v dash u equals to 0. Let's solve this here. So minus sin x cos 2x minus 2 sin 2x and cos x. Okay, so what I see is I see both having sine and cos. I don't see anything common, which is unusual, but it's there. Okay, so 2 sin 2x cos x comes here as a positive number, and this stays here. Let's see if I get to the correct answer. I have a feeling I may have made some error there. So what I'm doing is converting both to tan. 2 tan 2x, and then I apply my identity. That's 4 tan x. There's another mistake here. Oh, it's a simple question. I made it deliberately more complicated. Let's just do this again. So this was just 4 tan x instead of square x. I don't know why I wrote square x. So this becomes minus tan x plus tan cube x. Okay, bringing everything to one side, that gives me 5 tan x minus tan cube x equals to 0. So I think that should work. If it doesn't, I'm going to just do the entire question again. Let me just check now instead of going through the entire question. Tan inverse of, this gives me root 5. Yeah, it's fine now. Okay, either this equals to 0 or that equals to 0. Tan square x, tan x equals to root 5 or minus root 5. This gets obviously discarded. I choose my quadrant, quadrant 1, and I say that tan inverse of root 5 should give me the final answer. That gives me 1.15, and that is indeed the correct answer. Okay, sometimes mistakes happen, and there's just small mistakes that you overlook. Okay, continuing with our questions, this is question number 7. It says a curve has equation e power 3x divided by tan half x. Find the x coordinates of the stationary points of the curve in the interval this, giving your answer correct to 2 decimal places. So I want to calculate dy by dx. This looks like a quotient rule to me, so I'm going to go on and do that. Tan half x and u dash is 3e3x. V dash is half sec square half x. Dy by dx is then u dash v minus v dash u over v squared. So 3e3x tan half x minus half sec square half x into e power 3x. Again, I need to equate this to 0. So 0 equals to, and I see a common e power 3x. So I get 3 tan half x minus half sec square half x. So either e power 3x equals to 0 or 3 tan half x equals to 0. 3 tan half x minus sec square half x equals to 0. Now I need one consistent trigonometric ratio here, so I'm going to replace this with 1 plus tan square half x. That's the identity for sec square. I get 1 plus tan square half x equals to 0. So this opens up to give me this. And what I see is a quadratic equation with tan x as my variable. So minus tan square minus half tan square half x plus 3 tan x minus half. I'm going to use my calculator to solve the quadratic and see the two answers that I get. 3 and minus half. So I'm getting tan x, tan half x as 5.828, and the other one is tan half x equals to 0.171, 172, 1716. Okay. So both are in quadrant 1 and quadrant 3. Needless to say that quadrant 3 is going to be discarded. There are going to be two alphas, both of which will probably appear in quadrant 1. Tan inverse of 5.828. That gives me 1.4 into 2, 2.80. Okay, yeah, that's the answer that I'm getting. 1.401, and this one is, so half x equals to 1.401 in quadrant 1. That gives me x equals to 2.802. That's one of the answers. And tan inverse of 0.1716. That gives me 0.1699 into 2, 0.340. So quadrant 1 half x equals to 0.1699 and x is therefore equals to 0.340. Those are the two answers. That's what the question was asking, giving your answer correct to uh, 3 decimal places, and I wanted the turning points. Moving on to the next question, this says the equation of a curve is this. Find the x coordinates of the stationary points. Again, I am asked to find the coordinates of the stationary points, so I am going to start off with dy by dx. I think the first one looks really relatively simple. 3 sine x will simply become 3 cos x. For differentiating this, I will first consider this as power outside the bracket. I will differentiate the power, put a power outside, and then differentiate what is inside the bracket. So 3 cos x minus 12 cos square x sin x. Okay, then equating this to 0, I see cos x as common, so I'm going to say 3 minus 12 sin x cos x. So either cos x equals to 0 or 3 minus 12 sin x cos x equals to 0. Now for cos x equals to 0, I can mark all 4 quadrants, or I can just imagine where cos would be 0, that is at 90 and 270. If I remember that, I should do that directly. If I don't, I should just mark my quadrants, go with cos inverse of 0, which gives you pi over 2. So quadrant 1 is pi over 2, quadrant 2 is pi minus pi over 2. Okay, so that gives me also pi over 2. So I am restricted by the range from 0 to pi, so I will stop at 180. I won't go into quadrant 3 and quadrant 4. Had it been a complete cycle, I would have done that too. Solving this, I don't have one consistent trigonometric ratio right now. Let's try to move things around and see what we get. Now, the only way of changing this into one consistent trigonometric ratio is to sort of use the identity. What identity am I talking about? Sine 2x equals to 2 sine x cos x. So sine x cos x is basically sine 2x divided by 2. So can I replace this with sine 2x divided by 2? Okay, so that gives me 6, 3 over 6 sine half x. Quadrant 1 and quadrant 2, alpha is sine inverse of 3 over 6, which is half. That should give me pi over 6. So I'm going to say that quadrant 1 equals to half x equals to pi over 6. Sorry, 2x, not half x. This is 2x. My bad. I was just carrying on with that other question. 2x equals to pi over 6. And quadrant 2 is 2x equals to pi minus pi over 6. So I get pi x equals to pi over 12 and x equals to 5 pi over 12. So I have 3 turning points, 1, 2 and 3. Then it says determine the nature of the stationary points in the interval for which x is least. Now what you've done in the past is that you always found out the double differential. But when I just look at the double differential, it looks very complicated. Why? Because it has a cos x term, then I'm asking you to do a product rule, and that seems like an exaggeration for just 2 marks out of the entire question, right? So what other method is there, and we've done this in class as well. What you can do is, I just want you to figure out whether the least turning point is a maximum point or a minimum point. So the least is pi over 12. So what I'm going to say is that I have pi over 12, which in decimals is 0.262. So what I'm going to do is I'm going to choose a value right before it and say that I am picking out the value 0.260, and I am going to take a value right after it and I'm going to say 0.265. What I'm going to do is I'm going to use my dy by dx and calculate that at 0.260. So I write down 3 cos of, or I can also write it down in the simplified form. I can write down cos 0.260 into 3 minus 12 sine 0.260 into cos of 0.260. Okay, let's calculate that. That's all in radians. You should be able to do that. 0.260 into 3 minus 12 into sine 0.260 into 0.260 into cos of 0.260. So that gives me a positive number 0.018. Then I'm going to do the same thing and find for you 0.265 by inserting the number here as 0.265. Okay, so cos of 0.265. And that gives me minus 0.032. I've done 0.260 and 0.235. So what I know is that if my turning point is at 0.262, right before the turning point I have a positive gradient, which means that the line is going up like that. And after that I have a negative gradient, which means that the line is going down like that, which means that this turning point must be a maximum point. The nature of the gradients is telling me that the line is rising first and then falling, therefore the gradient is first rising and then falling, and I get a maximum point out of this, and that's the correct answer. Had you done the double differential and you would have inserted, you would have gotten the exact same answer. What I did was I avoided an unnecessary product rule in the question. Okay, question number 9. It says by differentiating 1 over cos x, show that y equals to sec x. So y equals to sec x. Let's see if my pencil is charged. My pencil has lost. Okay, question number 9 says by differentiating 1 over cos x, y equals to sec x. Then dy by dx is this. So dy by dx should be, I bring cos x up and I say that this is cos x power minus 1. So this becomes minus 1 cos x power minus 2 into minus sine x. So the differential of cos x is minus sine x. So this gives me sine x divided by cos square x. When I have that, I can then, in order to prove that it is sec x tan x, I can just say that I can separate the two cos in the denominator and say that this is basically 1 over cos x separately. So that gives me tan x and that gives me sec x. So that becomes sec x tan x. It's part 1. Part 2 says show that 1 over this is that. Now the simplest idea that I can explain to you over here, and so it's just a 1 mark question, is that you see what I need is I need to show that something in the denominator has come into the numerator with the change sign. So I said if I need that in the numerator, why don't I multiply 1 with that expression in the numerator? But I can't simply go on and do something in the numerator, it distorts the balance. So what I need to do is I also need to write something in the denominator, and that's the exact same expression. What that does is it creates a balance, and I have my required numerator, but I don't have my required denominator. I need nothing in the denominator, and let's see what happens here. I have sec x plus tan x into sec x minus tan x, which should give me sec square x minus tan square x in the denominator. Now, as you remember from before, sec square x can be replaced with 1 plus tan square x. So that helps me. And I get sec x plus tan x divided by 1. So that's the proof for this question. Slightly longer because I did a lot of steps. You could have just multiplied it across in the first go. Okay. The third part says deduce that this is equals to that. I think that's also relatively simple. 1 over sec x minus tan x. There's a square, so why don't I say that this is a whole square? One could we can square one as well. Uh, I know that I just proved to you in the previous part that this denominator can then be written as a numerator, and I can say that this should become what? This should become sec x plus tan x whole square. When it becomes that, I expand it, and I need to get rid of the tan. So sec square x, and tan square x can be written as sec square x minus 1. I hope everybody remembers this identity that I've used twice in this question. Okay, so I get 2 sec square x minus 1 plus 2 sec x tan x. And that is the answer to this question. Okay, so this is the last question. It says a curve has equation this. Find the equation of the tangent to the curve. So when I'm looking for the equation of the tangent to the curve, what I need to do is the product of the quotient rule. In this case, I get 0 minus sec square x, and v is 1 plus tan x, and v dash is 0 plus sec square x. So dy by dx then becomes u dash v um, minus v dash u over v squared. So I'm calculating the gradient of the tangent. I need to calculate it at the point dy by ds at x equals to pi over 4. To be honest, I can plug everything on a calculator. I just have to make sure that I write down sec correctly. So 1 over tan pi by 4 minus sec square pi by 4 into 2 minus tan pi by 4 and 1 plus tan pi by 4 whole square. Tan pi by 4 is easy. Even if I don't calculate those individually, I can just say that uh, cos pi by, I know that it's 1. I can just put it on a calculator and calculate. Cos pi by 4 squared is half, which means that sec square must be 2. So minus 2, 1 plus 1 minus 2, 2 minus 1 over 1 plus 1 squared. So I get minus 4 minus 4 minus 2. So that's minus 6 over 4. That's minus 1.5. I want to calculate the equation of the tangent, so I need the y coordinate as well. 2 minus tan times pi over 4 over 1 plus tan pi over 4. So that gives me 2 minus 1 over 2, which is half. So y minus y1 m m x minus x1. So I get y equals to minus 1.5x plus 1.5 pi over 4 plus half. Let's see what I get that in decimals, because I need a decimal number here. That's what the requirement of the question is. I am not creating that requirement. So I get minus 1.5x plus 1.68. That brings us to the end of the second marathon. I hope this was productive for you. Please ask your questions in the comments, and please make sure to like and subscribe for more videos. Thank you.